Hey y'all, Miss Mayhew here, and I'm going to go through an activity with you guys on macromolecules and SEM bars. So let's get started. What we have here is a scientific question. This activity is asking, how does solubility change in response to decreased oxygen, such as in lipids? So this is an example of our classic lab design stuff. So I want to point out the independent and the dependent variable. So we're looking at how solubility changes in response or depending on decreased oxygen. So my solubility is going to be my dependent variable. The decreased oxygen, on the other hand, is my independent variable. That's what we're manipulating to see how it affects the solubility. So your hypothesis could be one of several things. You're going to hypothesize as oxygen decreases, the solubility is going to, you could say increase, you could say decrease, or you could say stay the same. Whatever you predict is fine, as long as you're able to recognize that the solubility is what's changing in response to that decreased oxygen. Now, another part of the scientific design and lab design stuff that we always go over are variables that could be held constant in this experiment. So, some of the things that could be held constant might be the amount of each of the macromolecules they're testing. Maybe they measured out the same amount of carbohydrates and lipids, or the same volume of water that they put both of them in, or the temperature that both of them were tested in, or any other number of things that they could have held constant that seems reasonable for this experiment. Now, one of the things that this method summary is talking about is identifying the carbohydrate and the lipid. Now, based on what we know about carbohydrates and lipids, we know that they're both made of carbons, hydrogens, and oxygens. Another thing we know is that carbohydrates are typically found in this 1 to 2 to 1 ratio. So what I'm going to do in order to tell the difference between the two based on these diagrams is count the number of carbons, hydrogens, and oxygens in both, starting with carbons. My first one, I have 1, 2, 3, 4, 5, 6 carbons. My second one, I have 1, 2, 3, 4, 5, 6 carbons as well. Now I'm going to go through and count hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on my first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in my second one. And now the number of oxygens. 1, 2, 3, 4, 5, 6 in my first one, and 1 in my other one. Now, if I simplify these, this turns into 1 to 2 to 1. This one stays 6 to 12 to 1. So, based on those numbers, I would assume that this first one is my carbohydrate, and my second one is my lipid. So now let's look at my data and get ready to graph it. So first thing I want to do is set up my graph with my independent and my dependent variables. We've already mentioned that the dependent variable is going to be the solubility, or in this case, the percent of soluble compounds. My independent one is going to be the amount of oxygen, or in this case, we've divided into carbohydrates, which have more oxygen, and lipids, which have less oxygen, as you can see when we counted them up above. So I'm going to put my independent variable, or the amount of oxygen in each of these macromolecules, along my x-axis. And on my y-axis, I'm going to put my dependent variable. In this case, the percentage of soluble compounds. Now, the next thing I'm going to do is figure out a scale. So I have 10 lines here going up. on my y-axis. So since we're talking about percentages, it would make sense to do each line representing 10%. Now I'm going to graph my bars for each of these macromolecules. My lipids, I have 9% soluble. So I'm going to draw my box up here at 9%. My carbohydrates, on the other hand, are 73% soluble compounds. So I will draw my box up here to around 73%. In my table, I also have my 2 standard error of the means. So I am going to add and subtract that number from my average. So for lipids, I'm going to add 1.5 to get the top of my SEM bar, which will give me 10.5. And the bottom is going to be 9 minus 1.5, which would be 7.5. For my carbohydrates, this 2-SEM is 2.84. So in order to get the top of my SEM bar, I will add that number. So that would give me 75.84. And to get the bottom of my SEM bar, I'm going to subtract 2.84 from 73, which will give me 70.16. So as we've discussed in previous SEM bar activities and lessons, whenever the SEM bars do not overlap like they do in this picture, then we know that there is a statistically significant difference. You can see that carbohydrates have a higher percentage of soluble compounds than lipids. So carbohydrates that have more oxygen are more soluble than lipids, and we can see that there is a statistically significant difference. So my claim, based on this data, would be that carbohydrates, or the question asking about decreased oxygen, I would say that as oxygen decreases, like in lipids, the solubility decreases as well. So that's my claim. My evidence is going to be what I looked at in the graph to make me come up with that claim. In this case, it is those SEM bars that show that statistically significant difference. So I could say that the lipids that have less oxygen have a statistically significant difference and are lower than carbohydrates that have more oxygen. Now, explaining the reasoning and why the evidence supports your claim is really where you get the opportunity to connect the data back to what you learned about the properties of water. Remember, whenever they want you to explain your reasoning and tie it back to your previous learning, you want to try and get 3 levels of explanation. So you could talk about how you know that water is polar. It has an uneven charge distribution. And because it's polar, it dissolves polar things as well. Now, what makes water polar is that it contains that oxygen that's more electronegative than the hydrogens, which keeps that negative side over on the oxygens. We also know that because water is polar, other polar molecules are going to dissolve in it. Now, adding oxygens, which we've already discussed are electronegative, is going to increase that molecule's polarity, okay, making it more likely to dissolve in the water. That's it for this video. Hopefully you guys got a lot of good practice and were able to work through some of these and check yourself. If you have any questions, please feel free to email your teacher. Bye!